Thank you very much for your time. My talk this morning is titled "Do Not Make the Cloud a Landfill for Your Subsurface Data." Cloud storage offers many benefits to oil and gas companies, with many companies moving applications and their data to the cloud. However, without establishing best practice, there can be risk. There isn't always the time to properly label your data. There's often pressure to make decisions quickly, driven by a need to save money or make way for incoming data following a merger. There might be strategic drivers where the company has opted to focus on new assets and the previous work is no longer needed. Time constraints, financial pressure, resource constraints, and strategic change might result in data being bulldozered off to the cloud without first considering the appropriate policies that help govern this valuable data. Do not make the cloud a landfill for your subsurface data. Does this sound familiar? From a recent phone conversation with my parents, they said, next time we come up, we're going to bring some boxes from the loft. They don't know what's inside the box. It has no label except that it says Paul's. There is no understanding of the value. It could be fragile, or it might be an unwashed rugby top from the 1980s. They've not asked me if I want it, but they're planning on renovating the roof space. They're going to go to the time and effort of going up to the loft to bring it down, pack it in their car, drive it 600 miles to my home for me to take a look at. Now, I'm sure there'll be some gems from my past that I will enjoy seeing again, and there may be some items that I want to keep, but I suspect much of it will be disposed of shortly after my parents head home. If only I could look into the box while it was still in the loft before they go to all the effort of bringing it up to me. So after much of the box was thrown away, there were items that I wanted to keep, but it still included inoperable hardware, unplayable media, unusable currency, unwanted gifts and prizes. The volume of data, personal items, that an individual might collect and retain is dwarfed by the volumes of data that can be acquired by oil and gas companies. A storage box, a standard box holding about 2,000 sheets of paper, equates to about 10 megabytes of data. A petabyte of data, which is 1,000 terabytes or 1,000,000 gigabytes, is the equivalent of 100 million paper-filled boxes, which if placed side by side would almost match the Earth's circumference. 12 petabytes of data, and Discos currently holds 11.5 petabytes of seismic data, is the equivalent of 1.2 billion storage boxes filled with paper. Side by side, the boxes would stretch from the Earth past the Moon. Oil and gas companies own significant volumes of data, and as mentioned, time constraints, financial pressure, resource constraints, and strategic change might result in data being bulldozered off to the cloud without first considering the appropriate policies to help govern this valuable data. The benefits of establishing best practice when working on the cloud, particularly following mergers or after years of unregulated expansion, are to archive older inactive projects and to make it easier to find and manage important active data, and to improve the active data record by removing duplicates, and to make significant savings on the costs and management of active disk. So we'll focus on the use of the cloud for archiving data, selecting only the appropriate projects to be archived, and how we can help improve the quality of the active data record. Establishing best practice policies for archiving data can lead to savings from tens to hundreds of thousands of dollars per year, be it through choosing more cost-effective storage or through reducing the need for expensive hardware and its upkeep. So our approach using IOV is first of all to discover the data active on-premise, be it on legacy or cloud data platform environments. We then automatically search and liberate and normalize your metadata and spatial data. And we visualize and analyze your results, identifying duplication, poor quality, and more through the use of open APIs. And this allows us then to build workflows based on your policies to automate data movement to cost-effective long-term storage, including disk and tape. And because data management is an ongoing process with new data being interpreted and potentially more data being added through acquisition, we need to manage the data environment, and we can do this using automated summaries and alerts when new data is found. When opting to use the cloud as part of a data management strategy, it is necessary to capture extensive metadata to aid the search, filtering, and analysis. Only then can data managers make informed decisions and build the appropriate policies to effectively manage the data, leading to savings on active disk space required and the timely access of the entire subsurface data record. All metadata is stored in a graph database, providing powerful input to visual analytic options using our IOV interface or through open APIs to third-party applications. There is integration with a wide range of geoscience applications, and the technology automatically discovers projects and datasets. Enterica OneView is designed to discover data on Windows and Linux storage, and now extended to support the OSDU data platform. When using IOV, the interface is designed to provide you with visibility on your active data and simultaneously your archive data. From the metadata that we have collected, we can filter to refine our views, and we can save views and reopen these later if we wish to continue our work. And we can then visualize our data spatially in charts and in histograms. We can create charts and plot file size versus create date. We can see the active projects in yellow and the archive projects in purple. And this can help us identify large projects that may not have been used for some time. And we can then investigate these projects further and choose the action to take. We can display all active projects by application type, and we can choose to display all live projects by user broken down by application. We can search through all of the data and apply filters. We can look for projects that could contain a name, for example, South, and apply an additional filter that includes projects found using the Petrel connector. Having applied our filters, we can now review our well data, including POPs and logs and check shots, all the information that you would find associated with a well, and the seismic data, including the interpreted data, such as horizons. We also have the option to visualize the active seismic volumes. The important consequence of having gathered extensive metadata provides data managers with the ability to use this knowledge to optimize the management of their subsurface data. Arbor, which is our automated rules-based archiving system, allows you to design policies specific to your company's needs, which can be implemented either manually or automatically. And at the time that they are implemented, we can capture additional metadata during this process. Users can explore the content of the archive easily without having to retrieve it. And when archiving projects are restored, all or part of the archive can be restored to the original or to a new location. When it comes to building rules and creating jobs, we can create or edit existing jobs, we can write our own rules, or we can select from quick rules that are there just to help speed up the process. We can then configure what additional metadata we wish to capture when executing the job, such as who interpreted the data and what stage gate the project had reached and the associated approvals. We have visibility over all of the connections to all of the applications, and we can review and manage all of the connections to the destinations that we have configured. So for one of our major clients, we undertook a transformation program to improve efficient management and delivery of geotechnical project data. The pilot project was based on a dataset provided by one of the operator's asset teams and the system was accessible on the cloud. There are approximately 200 geoscientists working on the project daily, and the management wanted to declutter and prioritize the active projects to help focus on meaningful work. A key outcome of the project was to reduce the usage of disk by old Petrel projects, and this was automated through capturing metadata and then recommending archival or removal from the live system. Time was critical as the client was at a point where they would have increased their disk storage by buying another major rack, which involved a substantial capital expense. The solution was IOV, including Arbor, the Petrel application connector, our open APIs for integration with a global GIS system, and direct integration with AWS S3 for robust and cost-effective long-term storage. The savings recorded a total of $3 million, and that was largely down to a reduction in active projects and a reduction in the number of Iceland nodes that the IT team were able to turn off. So if only I could look into the box while it was still in the loft. Well, we can, and we can collect data now in our graph database. We can visualize that data, be it spatially, through charts, custom reports, and then we can take actions, decide whether we want to retrieve the data. So we could search for projects that contain a specific well or seismic, or work that was undertaken by a specific interpreter or had reached a certain stage gate, or if the project had been completed. And then we can take decisions regarding what happens next. We can restore the project for a user, restore and upgrade selected projects to the latest application version, or move projects to deep storage where they've not been referenced for a number of years. The benefits when implementing policies to manage data on the cloud include improved workflows and greater efficiency, so easily discover and analyze your data across all applications, manually make decisions regarding what happens, or develop rules to automatically select and take actions on your data. There can be significant cost savings by removing duplicate data or data that you no longer own, and archiving selected historical data or stage gate data to lower cost storage, and through reducing the need for expensive hardware and its upkeep. The solution is massively scalable. Purchase the space as required and as you increase the volumes of data that you archive on the cloud. It offers improved data access for all subsurface data is visible, both the active and the archived data, and it can be made available across the entire organization using the captured metadata. Users and data managers can identify data without reloading or reacquiring it and specify what actions to take. That's the end of my short presentation. If you'd like to contact me on anything, I've got my email on the screen, and it was relatively quick. I'd be happy to take some questions if you have them, or if you've put them in the chat, I'll revert back to that now. Samuel.
In terms of collaboration with OSDU and on-site and cloud, if your data is across these platforms, how does your case study did work in that scenario? And normally, how does, I mean, with the petabyte of data that you're referring to, how much, what was the turnaround with the case study where you were able to analyze and come up to that cost saving?
So on the first question, we would, it's more a case of configuration. So we're able to connect, and most of our clients have existing partnerships either with Amazon or with Microsoft, and we would connect to their cloud storage. And of course, the data that's on their system in their offices, we are able to connect through permissions they give us to various drives. And we configure those as in some cases as destinations, and in some cases where we need to scan and do the acquiring of all of the metadata. On the project in Australia, I don't have a time frame for how quickly we did that. We had on some work that I was involved in more recently, in terms of scanning projects, it took us about 48 hours to scan 600 Petrel projects, and we would do that over the weekend. When we do the scan, the deep statistical scans, we do require a Petrel license in order to open up the project. see what wells are there, what data is there. That then allows us to capture the information inside the Janus Graph database. So sometimes we can schedule them in evenings, mostly we do it at the weekends. More often than not, more than 50% of our customers' data are either duplicates or data that they wish to delete as an average across most of the work that we've done. Does that help, Samuel?
Yes, thank you.
Thank you. Any other questions? If not, we'll bring this to a close, and I thank you very much again for your time.